All right, so let's take a look at acid-base reaction. So this will be the only reaction I expect you to be able to predict. And what I mean by that is I give you the two or three reactants, and I expect you to be able to give me the mechanism and the product. So think back to Gen Chem or Gen Chem 101. An acid-base reaction is a transfer of an H+, otherwise known as a proton. You'll often hear it be called a proton. If you think about what a hydrogen is, it's a proton, an electron, sometimes a neutron, but most oftentimes not. And so if you take away the electron, then all that remains is a proton, right? And so think back to the nomenclature here. The acid is the H+ donor, and the base is the H+ acceptor. And so this kind of vocabulary kind of messes students up, but let's think about what's going to happen here. We're going to break the hydrogen acid bond. That way we can donate this H+, and then we're going to form the hydrogen base bond. That way the base is now accepting our H+. But remember, with reaction mechanisms, what we show is the flow of electrons, not of H+. So let's take a look at an example. So here we have hydroxide interacting with HCl, hydrochloric acid. So hydroxide is obviously the base, and hydrochloric acid is obviously the acid. And so what a lot of students will do, they'll think, oh, this H+ right here, it's going to go onto the hydroxide. So I'll just draw an arrow of this H going onto the hydroxide, right? But if you think about that hydrogen right there, there are no electrons, right? There are no electrons, so that cannot be the mechanism, right? Do not do that. Instead, what's going to occur is that the base is going to form the HB bond. So the electrons are going to come from the base, and they're going to attack our hydrogen. And then at the same time, this hydrogen and then acid bond, in this case, this chlorine, that bond is going to break, and the electrons are going to go onto the chlorine to give us our products, which will then be water and this chloride minus, right? And think about where these electrons came from and how they're being formed, right? This oxygen-hydrogen bond, the electrons came from this oxygen. And then this chloride, it got an extra pair of electrons from the bond, right? So the main thing here is that you want to show electron flow, not the flow of an H+. Alternatively, you can draw this in two steps. Let's take a look at some examples and see which way is correct and which way is incorrect. So let's think about doing this in two steps. And let's say we first have our hydroxide attack this H, and then draw the product. Right, the hydroxide has lost electrons, so it's become neutral. This hydrogen has now gained electrons, so it's negative, and then the chlorine has stayed the same. And so if you look at this product right here, we've got an issue here, and it's this hydrogen. Remember, hydrogen can only have 2 electrons or 1 bond. And so what we're doing here is we're breaking the duet rule. Right, same as the octet rule, except hydrogen is special. It only has 2 electrons. So we can't do this, so this mechanism is incorrect. Alternatively, let's take a look at it a different way. We have hydroxide and then HCl. Here we could draw the the breaking of the H acid bond first, right? So we have the electrons from the hydrogen and the chlorine go onto the chlorine. Right, so now we've got a hydroxide, an H+, and then a chloride. And then finally, we have the formation of our base H bond. So we have our hydroxide attack our H+. Think about the hydroxide is negative, the H+ is positive. When they combine, you'll form a neutral compound. And then you'll have chloride just kind of hanging about, right? And so this would then be a correct mechanism as well. So you can do it in 1 step or 2 steps. All right, so let's do one more example here between ammonia and hydrobromic acid. So go ahead, pause the video and give me the reaction mechanism for this. All right, hopefully you've done this. You've identified the hydrobromic acid is indeed the acid, which would make this NH3, this ammonia, the base. And so we have to form this base H bond. But if we think about it, where are these electrons coming from, right? So remember, again, with our organic structures, we don't have to show the lone pairs around this nitrogen, but that doesn't mean that they're not there, right? They're still there, they're just not shown. And these are indeed the electrons that are going to be attacking our H. And whenever we draw these mechanisms, our arrows always have to start at electrons. So you can show that starting off at a negative charge. And if you don't have a negative charge, then you do indeed have to show the lone pair. So we're going to form our NH bond. And again, the hydrogen cannot break the duet rule. So we're going to break this HBr bond simultaneously. Or you could do it in 2 steps. Just make sure you're breaking this HBr bond first. Draw our products. Right now, we've formed this nitrogen-hydrogen bond. And then we've kicked off a bromine. If we think about our charges, then our nitrogen was neutral. But now it's lost some electrons because it's donated them to the H. So it's going to end up being positively charged. The hydrogen has gained electrons from the nitrogen, but then lost the bonded electrons to the bromine. And so that cancels out. So the hydrogen stays neutral. And then finally, the bromine has now just gained electrons. So it becomes a negative charge or a bromide. So again, be able to do this, and all this comes down to doing some practice.